we look about the topic class imbalance. The class imbalance problem can occur only in classification tasks where we are supposed to classify the data samples. So, what is class imbalance problem? What is class imbalance means? When a data set has more number of samples for a particular class and very few samples for another class, then we call it as class imbalance. The reason why we call it as class imbalance is because one class is having many samples, many data samples, whereas another class is having very few. There is an imbalance between those two classes. The example class imbalance is not only for binary class, even in multi-class also it can happen. Like for example, if we have ABC classes, the dataset may have more number of samples for A and B, but not for class C. So that we call, then that dataset is having class imbalance. Here, let us consider an example. A dataset is having 950 samples that belongs to class A, 950 samples belongs to class A, and only 50 samples belongs to class B. So overall dataset has 1000 samples, in which only 50 samples belongs to class B, whereas all remaining samples belongs to class A. Therefore, this data set is highly imbalanced because uh, there are very few samples for class B. Okay, when there is a class imbalance in the data set, why we call it as a problem? Why class imbalance is a problem? The reason why class imbalance is a problem is because when we are designing a model for some classification task, for some class prediction task, what happens is the model looks more, the model learns more information from majority class. Majority class, we mean the class which has more number of samples. If 950 samples are there for class A, the model, any model, it could be machine learning model or deep learning model, it will learn more from majority class samples, from 950 samples, because only 50 samples are there for class B. So the model may not learn properly what class B samples are exactly. So such information model may not capture about the class B samples. Therefore, what happens is the model behaves biasedly. Why we call it as bias? Because model has seen more number of samples from class A and it know what exactly, it tries to identify the hidden patterns, hidden information, and it will understand. It could able to understand the distribution of class A samples. Whereas it may not understand because there exists only very few samples from class B. It may not understand properly what exactly the distribution of class B, and it may not able to learn proper information from class B samples. Therefore, the model behaves biasedly and would always lead to predict class A. Though there exist two classes in the dataset, it will always try to predict class A, which is a problem, which is not correct. Therefore, class imbalance is considered as a problem. Even it is the similar for multi-class also. If there are ABC classes, AB classes are having more number of samples in the dataset, the model will learn about more information from A and B classes samples only, but it may not learn proper hidden information from class C samples. Therefore, the model may not predict well at the test time for class C. I mean, like what happens is the model may predict the sample belongs to either class A or class B, though the sample belongs to class C at the time of test. Because it did not learn properly what exactly the class C samples are, what is the distribution of it. Therefore, that is the problem. That's the reason why we call class imbalance is a problem. And because of which there will be very less generalization and it performs biased. I mean, like I said, in binary class, when we are having both class A and class B samples, when class B samples are very less, though the model is trained. It will predict class A because it has seen more number of class A samples it have understood. So always it predicts class A. Therefore, there is no generalization. Okay, that's the problem. That is the reason why the information learned by the model is not proper because of the class imbalance. That's the reason why we call it as class imbalance as a problem. Okay, so when class imbalance is there, when we can tell the data set is having class imbalance, when we tell the data set is not class imbalanced. For example, consider here we are having a data set D1 with 95 samples, 95% samples belongs to class A and only 5% samples belongs to class B. Therefore, we can understand from the 100% from the total data set, only 5% samples belongs to class B and remaining 95% samples belongs to class A. Therefore, what happens is the model learns more information from class A and it may not learn properly from class B. If the overall data set is only 100 samples, 95 samples belongs to class A and only 5 samples belongs to class B. Therefore, it could not perform well. So we call this data set is having class imbalance. Let us consider another data set. Another data set D2, it is having 80% samples from class A and 20% samples from class B. Even this is also considered as a class imbalance problem, but not as high as for dataset D1. For dataset D2, class imbalance is there, but not the same severity as dataset D1. Okay. Let us consider another dataset D3. 60% samples belongs to class A and 40% samples belongs to class B. We will not consider this dataset D3 as class imbalance because there are good amount of samples for both class A and class B. So we are not going to consider this as class imbalance problem. Okay, we have discussed about the percentages. Fine. Let us take the first one. A dataset D1 is having 950 samples from class A and 50 samples from class B. This is definitely a class imbalance problem. Okay, that the model, like we are supposed to handle the class imbalance and we have to design the model. But let us consider another data set D2. Here it is having huge number of samples for both class A and class B. Is this still a class imbalance problem? Because actually class A is having more number of very huge number of samples, but but class B is also having good amount of samples. It is very less compared to class A number of samples, but class B is also having good amount of samples. Now, can the model perform better or not? Is this still a class imbalance problem? Think about this. This is not a class imbalance problem. At least the model will perform better because even though the number of samples between two classes is highly varied, the number of samples are highly varied between two classes, but still to learn the underlying hidden patterns and to learn the distribution of the samples, we got the required number of samples. Okay, at least for class B, you can understand. The model can learn the patterns from it. Therefore, when the model can learn the patterns from it, though there is a huge variation between class A and class B, still this is not a very huge problem or this is not going to severely affect the model's performance. Though the model performance will be affected little bit, but not as severely as for dataset D1. For dataset D1, if we give the dataset as it is to the model will be biased and will not be generalized. It will predict only class A most of the times. Okay, but in if we have dataset D2 and if we are giving the same dataset to the model can understand what are the hidden patterns or underlying distribution for class B samples. And it could able to discriminate between class A and class B. Therefore, the dataset D2 is not a big problem, but still it affects the performance of the model. There is a little effect will be there because there is a huge variation between class A number of samples and class B number of samples. Therefore, the model will be having certain effect on it, but not as huge as this one. Okay. So, when we call the class imbalance is also most important. And when we are having a class imbalance problem, how can we solve that? To solve the class imbalance problem, one thing we can do, we can increase the number of minority class samples. Minority we mean this the class for which very few number of samples are there. That class we call it as minority class. And if we try to increase by generating the samples, if we try to increase the class minority class samples, then we may match up and we can try. The model can learn the hidden patterns within the class. Or else, there is another way to reduce the majority class samples. But trying to reduce the data is not a good option, and we may lose certain information by choosing the second option by reducing the majority class samples. So we are supposed to choose the way to solve the class imbalance problem in a careful manner so that the model can learn better information. And this is what the class imbalance is all about. And thanks for watching this video. Thank you.